A black hole is an eerie place where those laws of physics we studied at school stop working. If a massive star runs out of its star fuel, it sometimes becomes super dense and buckles under its own weight, collapsing inward and bringing some space-time along. As a result, the gravitational field of this new object gets so strong that nothing can escape it, not even light. That's how a black hole is born. But there's another theory that if there's a space object nothing can escape from, I'm talking about black holes, there must be something into which nothing can enter. And if you support the theory that black holes don't destroy any information, there must be a way for this information to come back out. So, can this something helping information escape be a white hole? So far, white holes are only a theory. You can imagine them as black holes in reverse, or as a ball that falls to the ground and then bounces up again. In other words, everything that falls in bounces and comes out through the white hole. Another question is how white holes might form. One of the theories speculate that white holes could be a black hole that has almost collapsed in on itself and then exploded outward again. Of course, no one has seen it, but inside a black hole, there's likely to be a long tube that's getting longer and narrower until it reaches the point in which it gets so narrow that quantum effects make it bounce back. And then this super long and super narrow tube is getting thicker and wider again. And we've got a white hole on our hands. You must be wondering now what could make a black hole want to turn itself inside out. Quantum mechanics states that many things we perceive as continuous are actually granular. Let me give you an example. Light is not a continuous wave, it's made up of photons. So if we apply quantum mechanics to space itself, we'll find out that the cosmos is granular too. It means a black hole can't squeeze stuff down to infinity. At some point, it will reach its minimum size, and this matter, or whatever is falling down the black hole, will have to stop and bounce back, giving birth to a white hole. What matter might a white hole spit out? Some experts think it could be ordinary electromagnetic radiation. It'd probably be unrecognizable from what originally fell into the black hole, since things get horrendously squashed after entering black holes. Black holes are known to absorb everything, matter and energy. As for white holes, they would expel them. Plus, black holes have an event horizon. Once you pass it, you can't turn back. As for white holes, they would have a reversed event horizon. It would prevent anything from entering a white hole. There are other mysterious theories about white holes. For example, some people think they don't exist in our universe, but they do exist in another, parallel universe. And it gets even better. There might be some kind of door that connects the black holes of our universe and the white holes of another universe. No one knows for sure whether white holes exist. But interestingly, for almost a century, the theory of general relativity predicted the existence of black holes. And still, many people didn't believe they could exist. And look at us now. We even have beautiful photos of black holes. So we're kinda in the same situation with white holes. It's pretty plausible that they do exist, but so far, they haven't been observed yet, and their existence hasn't been proven. But based on the very nature of white holes, assuming they were real, if you decided to travel to one, you wouldn't be able to get too close to it, because it would push your spaceship away, preventing it from entering. Perhaps you would be able to hang out nearby, watching the white hole spitting stuff out, but nothing more. Maybe to travel through a white hole, you'd have to first enter a black hole. This process would be way easier, but much more terrifying, let me tell you. Let's choose a black hole first. Not to waste too much time and fuel, we'll take the closest one to Earth. This medium-sized monster lies about 1,000 light-years away. On the scale of the universe, it's just around the corner. More than 4 times the mass of our Sun, it's surrounded by streams of gas. One by one, gassy shreds send out the last flares of light before disappearing inside. There are 2 stars nearby, one orbiting the powerful space object and the other moving around this inner pair. Scientists think this black hole might be the nearest to Earth. It's also the only star system that contains a black hole visible to the unaided eye. Finally, you reach your destination, the black hole itself. Its gravitational field is so powerful that even light, including X-rays, can't escape it. That's why the center of the black hole is pitch black. It doesn't mean you can't see the hole. This greedy thing consumes all the matter that strays too close, squeezing it into a superheated disk of glowing gas. The black hole also bends light around it, which creates a circular shadow. You approach this chaos of heat and gravity in search of the event horizon. Every black hole has an invisible line in the sand. Cross it and you won't be able to escape, even if you're a beam of light. Beyond the point of no return, the gravity is just too strong. But the big circle in the middle is bigger than the event horizon. Anything that approaches the black hole first goes into orbit around it. Once it happens, there's no way back. Whatever this object is, it'll end up being pulled into the hole. This region before the event horizon is called the photon sphere, and it looks like the black hole's shadow, even though it isn't. If you got there and somehow managed to stay in one piece, you'd be able to see the back of your head. The particles of light from your head would orbit around the black hole at immense speeds and come at you from ahead. Unfortunately, you wouldn't manage to pull it off. Once you started your journey towards the center of the black hole, the difference in acceleration between your head and feet would be many thousands of Earth's gravities. You would be spaghettified, but I'll tell you about that a bit later. First, the material gets caught in the black hole's orbit and is squeezed into a razor-thin spinning band. Friction, heat, electric, and magnetic forces energize this disk, which makes the material glow intensely. The most massive black holes have such bright bands that they can outshine millions of galaxies. Inside this disk of glowing material, particles rub against one another. It slows them down and sends them straight towards the black hole's event horizon. If this friction didn't exist, the material would be orbiting the black hole for billions of years, like planets circle around their stars. Anyway, you eventually reach the so-called surface of the black hole. You can also call it the event horizon. It's not a real boundary or membrane. And you don't understand you've crossed it right away. It takes you several seconds to realize you won't be able to escape the black hole's clutches anymore. That's because the light, also trapped by the black hole's gravitational pull, is falling in along with you. It's not bright, but it's still there. The longer you fall, the more stretched, head to toe, you become. This process is what's called spaghettification. You also get squeezed around your midsection, and the beams of light surrounding you form a glowing band about your waist. The last thing you see is darkness. It feels as if you're landing on a massive, empty, pitch-black planet. What happens after that? You tell me. Can it be that you'll just come out of a white hole in another universe?
Imagine a giant star, a space object with ginormous mass, collapsing down into gravitational singularity. This is a region of space where the density of matter becomes infinite. In such areas, the standard concepts of space and time don't have any meaning anymore. No wonder such objects have captured our imagination. These days, we even have a few photos of black holes, or rather, the space around them. The first photo of a black hole's event horizon was taken in 2019. The event horizon is a point of no return on the outskirts of a black hole. When something, for example matter, radiation, or light, reaches this boundary, there is no way for it to escape. We can use the event horizon to estimate the size of the black hole. The larger it is, the more massive the black hole you've come across is. An international team of scientists that consisted of more than 200 astronomers had been working for years to get this result, and eventually their efforts paid off. The black hole, the region around which they managed to capture, is about 55 light-years away from Earth, at the center of the galaxy M87. People saw this amazing image thanks to the work of a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. Scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 radio telescopes. But it was tricky. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. But even though now we kind of know what a black hole looks like from the outside, we haven't figured out what might be waiting for us on the other side. Many people imagine black holes as bizarre portals to other worlds, dimensions, or parallel universes. We'll get back to these theories a bit later. So, why not jump into a black hole and go all the way to the other side? Unfortunately, such an escapade is bound to end tragically. If something gets close to a black hole, there's no escape. You might argue that you don't need to go back. After all, you want to explore what's ahead. True, but there's another problem. The force of gravity around a black hole increases dramatically the closer you come. It even creates the effect of spaghettification, when an object gets stretched into thin strands of space pasta due to the effects of gravity. When spaghettified, the matter then gets pulled into the black hole's orbit and flattened into a swirling and glowing disk of material. And eventually, this matter settles into a nice orbit around the black hole, quite far away from the point of no return. And that's not how you want your space adventure to end. Well, I don't. Getting something to cross the event horizon isn't as easy as it may seem. The material needs to be pushed out of its stable orbit around the black hole. In other words, something must make it fall in, just like it happens with the Sun and Earth. Despite the star's enormous gravity, our planet doesn't get pulled towards it, right? One of the few reasons why the material might cross the event horizon is collisions between particles. By crashing into one another, they gain some energy, and that's enough to send them spiraling into a black hole. An object entering a black hole is instantly transformed. From the outside, it would seem as if the object starts moving more slowly, because time distorts near the event horizon of a black hole. From the perspective of the object falling into this space monster, it would take an infinite amount of time for it to become a part of the black hole. When it happens, its mass will be added to that of the black hole. But even if you somehow manage to survive entering a black hole, you wouldn't be able to come out on the other side. Now, I might disappoint you right now, but black holes don't go anywhere. There aren't any holes involved. And these space phenomena aren't even black, or at least that sort of black. Black holes might seem inky because even light can't escape their clutches, but this has nothing to do with their color. Anyway, when you cross a black hole's event horizon, all paths lead to the singularity, even if we talk about a photon of light moving directly away from it. But the main problem here is that singularities are mathematically impossible. That's why some scientists suggest that when all this weird stuff happens inside the black hole, its mass gets linked to the expansion of the entire universe. And such a black hole is like a rubber band, stretching along with the universe as it expands. And as it stretches, its energy increases. And since mass and energy are proportional, the mass of the black hole increases too. But this new mass creates a pressure that makes the universe expand even more. That's the reason the universe is expanding faster and faster all the time. Wow, that sounds insane. Then, there's also a theory about parallel universes, and this multiverse theory takes it all one step further. Those who believe in it state that there might be countless realities. According to this theory, we live in a bubble that is just one of many other bubbles, and these bubbles constantly pop up and vanish. And guess what? Right, black holes might be tunnels between these universes, or rather, not tunnels, but wormholes. This idea that black holes could be wormholes leading to other galaxies or universes has been around for some time. It gained some fresh ground in the 1980s when a discussion started about whether an object could physically travel through such a tunnel. But since there's no firm evidence that a black hole can allow for such a passage, this remains just an idea. But if black holes lead to other galaxies or other universes, there must be something opposite to them on the other side. That's where the concept of white holes comes into play. So far, white holes are only a theory. You can imagine them as black holes in reverse, or as a ball that falls to the ground and then bounces up again. In other words, everything that falls in bounces and comes out through the white hole. But how might white holes form? One of the theories speculates that a white hole might be a black hole that has almost collapsed in on itself and then exploded outward again. What if, inside a black hole, there's a long tube that keeps getting longer and narrower until it reaches the point in which it gets so narrow that quantum effects make it bounce back? And then the super long and super narrow tube is getting thicker and wider again, and we've got a white hole on our hands. But then, what could make a black hole want to turn itself inside out? According to quantum mechanics, many things we perceive as continuous are granular. Even light is not a continuous wave, it's made up of photons. So, if we apply quantum mechanics to space itself, we'll find out that the cosmos is granular too. It means a black hole can't squeeze stuff down to infinity. At some point, it will reach its minimum size. And this matter, or whatever is falling down the black hole, will have to stop and bounce back, giving birth to a white hole. What matter would such a white hole spit out? Some experts think it could be ordinary electromagnetic radiation. It would be unrecognizable from what originally fell into the black hole, since things get horrendously squashed after entering black holes. And while black holes have an event horizon, white holes would have a reversed event horizon. It would prevent anything from entering a white hole. And because of this feature of white holes, if you decided to travel to one, you wouldn't be able to even get close to it. Despite how much we already know about black holes, there are things that are still a mystery. For example, these space monsters seem to gain weight even when there's nothing for them to feed on. This realization might shed light on mysterious dark energy, but I'll talk about that a bit later. Most supermassive black holes lie in the centers of their home galaxies. You can probably say that they sit in the gravitational driver's seat. Meanwhile, hundreds of billions of stars, planets, and moons orbit them. Even though black holes are really, really big, physics makes it almost impossible for them to grow. But we've found one of these space wonders that has swollen to really unimaginable proportions. The black hole I'm talking about is TON 618, and it's a mind-boggling 66 billion solar masses. The thing is so massive that astronomers had to think of a new term to describe it. They came up with an ultramassive black hole. Imagine gathering all the stars in our home Milky Way galaxy and squishing the matter they're made of into one black hole. And it still won't be enough to create a TON 618. So the question is, how did this ultramassive black hole turn into such a behemoth? You probably know that black holes are made of matter packed together as densely as possible, to the point where gravity gets so powerful that not even light can escape it. And still, it doesn't mean that black holes are some kind of space predator, roaming galaxies and munching on everything they come across. TON 618 still has a whole galaxy filled with stars and other stuff happily orbiting it without getting pulled inside. What I want to say is that the perception of black holes as giant vacuum cleaners is wrong. In reality, it's incredibly hard to grow a black hole. Try to do it and you'll see. First of all, the material needs to get close enough to be affected by the black hole's gravity. And that's not so easy, considering how vast the universe is and how relatively small in size black holes are. But if something does get close enough, there's no escape. That's true. The force of gravity around the black hole increases dramatically fast. It even creates the effect of spaghettification, when an object gets stretched into thin strands of space pasta due to the influence of gravity. Once spaghettified, the matter then gets pulled into the black hole's orbit and flattened into a swirling and glowing disk of material. Eventually, this matter settles into a nice orbit around the black hole, quite far away from the point of no return, also known as the event horizon. By the way, we can use the event horizon to estimate the size of a black hole. The larger it is, the more massive the black hole you've come across is. Interestingly, getting the matter to cross the event horizon will be the most difficult part if you decide to grow yourself a black hole. You'll need to push the material out of its stable orbit around the black hole and make it fall in. As an example, we can take the Sun and Earth. Despite the star's enormous gravity, our planet doesn't get pulled toward it. And the main reason why the material can cross the event horizon is collision between particles. This way, they gain some energy, which is enough to send them spiraling into the black hole. But what happens afterward? The center of the black hole likely collapses into something called a singularity. That's infinitely dense material crammed into an infinitely tiny point in space. But the main problem here is that singularities are mathematically impossible. That's why some scientists suggest that when this weird stuff happens inside the black hole, its mass gets linked to the expansion of the entire universe. Yep, when it gets weird in space, it gets really weird. Such a coupled black hole is like a rubber band being stretched along with the universe as it expands. And as it stretches, its energy increases. And since mass and energy are proportional, the mass of the black hole increases too. But this new mass creates a pressure that makes the universe expand even more. That's the reason why the universe is expanding faster and faster all the time. But several scientists have suggested that, instead of a singularity, there might be something very different in the heart of the black hole – vacuum energy, which is one form of dark energy. Okay, but what is this dark energy? Everything on Earth and everything people have managed to see in space with the help of telescopes and other instruments is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Around 27% of the universe is dark matter, and almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if, several decades ago, they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite, it was accelerating. It meant there had to be some enigmatic force counteracting gravity, and it got dubbed dark energy. The European Space Agency's Planck satellite helped astronomers calculate how much dark energy the universe has to contain to explain the way its expansion is constantly speeding up. Scientists have also built models of how many giant stars formed and collapsed into black holes since the beginning of the universe. The conclusion is very exciting. The vacuum energy in these black holes is almost the same as the amount of dark energy that should exist in the universe. The scientists who conducted these experiments don't claim to have found the answer to the mystery of dark energy or to what we could see inside a black hole. But still, their theory is quite plausible. It can be tested with modern computer simulations and new data received from cutting-edge telescopes and other equipment. And now, let's speak a bit about dark matter. What it is and what it consists of. Actually, this is another thing that confuses scientists to no end. If dark energy is a force responsible for the expansion of the universe, dark matter is supposed to explain how objects work together. Potential candidates for dark matter vary from strange particles to super-dim objects. But even though astronomers can't grasp what exactly dark matter is, they know for sure what it isn't. It is dark, which means we can rule out visible stars and planets. It also can't be dark clouds of normal matter, otherwise scientists would be able to detect it. Dark matter is not antimatter. Astronomers don't see unique gamma rays that appear when antimatter comes in contact with matter. And neither is dark matter gigantic galaxy-sized black holes. There's one theory, though, and it's linked with a hypothetical concept of primordial black holes. Scientists have never got any real proof of their existence, but they think these black holes might be insanely old and quite tiny, by black hole standards, that is. Astronomers believe they could appear several milliseconds after the Big Bang. At that time, stars and galaxies weren't born yet. It means primordial black holes probably witnessed the entire history of the universe. By now, the smallest primordial black holes would have most likely evaporated away, but the bigger ones might still be scattered out there in space. Interestingly, these holes might be so small exactly because they popped up right after the Big Bang. The longer it took a black hole to appear, the larger it was. The mass difference between older, smaller, and younger, bigger black holes is incredible. Compare the mass 1,000 times greater than our Sun to that of a jelly bean. Yeah, you get it. So, there's this theory that primordial black holes could actually be dark matter. This idea remained unpopular for decades. But recently, scientists have realized there are many more black holes in the universe than they used to think. And it means the theory might actually work. And the vast and still hidden from us population of Big Bang black holes could not only make up, but be dark matter. After all, astronomers haven't discovered a single dark matter particle yet, even after decades of searching. At the same time, some scientists argue that dark matter can't be tons of multi-sized primordial black holes. They would collide far too often for this to work out. So, if you have a problem with all this stuff, just ask your nearest scientist, "Hey, what's the matter?"